Hello, geometry ladies and gentlemen. This whole video is going to be talking about postulates and theorems and how those things are related to algebra. So geometry is a totally different type of math, and so far in your mathematical careers you've talked about some things with geometry, but mostly you've worked with algebra and numerical sense. So now geometry is going to take all your algebra skills and extend it further onto shapes. And so when we talk in geometry, we're going to be talking about these things that are called postulates and theorems. So what exactly are postulates and theorems? So a postulate is a statement that is assumed to be true without proof. And a theorem is a statement that can be proven true, and it can also be proven false. So a postulate is like, you don't have to prove to me that you exist in this world. Like, I can assume that because I see you face to face in class all the time. So I don't have to prove to somebody that Timmy is existing in the real world. But I may have to prove that Timmy's favorite subject is math. So that's like the concepts that we're talking about. So we'll look at some examples of what like postulates and theorems are as we go on throughout the year. Okay, so here are some postulates that you probably want to write down in your notebook. And I believe that the pictures are in your foldable for you. So here are some segment and angle postulates, or things that we can assume are true without having to prove them because it just makes logical sense. So like the ruler postulate says that the points on a line can be given coordinates, and we can use those coordinates to find a length or a distance, right? So like when you measure something with a ruler, like you just take the ruler for granted. We don't have to prove that that ruler makes sense, if that makes any sense for the ruler postulate. And then if it goes on further, the segment addition postulate is saying that if we have multiple segments on that ruler, we can add them together to create larger segments. So like in our head, if you add things together, stuff gets bigger, and you don't have to prove that that happens or that is true. That's just a postulate. So if you want to take a couple seconds to write down these postulates or these words in your foldable, that would be awesome. Okay, and then we have more, and now we're talking about angles specifically, not just segments. So the protractor postulate is the measure of an angle is the absolute value of the difference of the real numbers associated with the sides. So what we mean when we say that is that when you have a protractor, this is like a protractor, right? We're saying that the degree of this angle can be found between these two ticks. That's how we're going to measure it. And we don't have to prove how we're measuring it. We're just saying like we can assume that that's how we measure angles. That's the protractor postulate. And then the angle addition postulate is just saying, hey, if we have multiple angles, so if we have like this angle and this angle, if we add those together, obviously it's going to create a bigger angle. So the angle and segment postulates are very similar. We don't have to prove how to measure segments or angles. We can just assume with a ruler and a protractor, and then when we add them together, obviously it's going to make a bigger segment or a bigger angle. So those are what we talk about with postulates. So now let's do some examples knowing those two postulates, okay? So given that the ray BX bisects the angle ABC, and the measure of angle ABX is equal to 5x, and the measure of XBC is equal to 3x plus 10, find the value of x and the measure of the whole angle. So let's start with a picture. In geometry, if they give you a bunch of words and a bunch of vocab and a bunch of notation, and you don't know how to make sense of all this, that means you need to draw a picture, okay? So given the ray BX, so we know a ray starts at one point and goes on forever at the next point, and if we look at this notation, that means that this is B and this is X, and it's going to bisect the angle ABC where this is my vertex of that angle. So bisecting means that this is congruent to this, and so my point A is going to be here, and my point C is going to be there, okay? And so they told me the measure of ABX, that's this guy right here, is 5x, and the measure of XBC, angle XBC, is 3x plus 10. We need to find the value of x and the measure of angle ABC, the big angle. Okay, so first we have to find x. So we're going to have to set up an equation in order to solve for x. So what do we know from all the information that they gave us? There's a key word in here that's going to tell me how to set up this equation. The word bisect means that it's going to cut into two congruent pieces, right? So that means that this is congruent to that, which means that we can set those two things equal to each other. So we have 5x is equal to 3x plus 10, and now all we have to do is solve. So subtract 3x from both sides. You're left with 2x is equal to 10, divide by 2, and now x is 5. Am I done with the problem? No, I'm not done with the problem. I still have to find the measure of ABC, that angle, okay? So that means that I'm going to have to plug x back in to find the measure of angle ABC. So that's going to be 5 times 5 plus the other angle, which is going to be 3 times 5 plus 10. So that's going to be the measure of angle ABC. So 5 times 5 is 25, 3 times 5 is 15. Those are all going to get added together, so 25 plus 15 plus 10. 25 plus 15 would be 40, plus 10 is 50 degrees, is the measure of angle ABC. And so that's example number 1. Okay, so now we're going to look at an example for segment addition. So remember, we're going to have to draw a picture because they didn't give us a picture to start with, okay? So as we read, I'm going to be drawing the picture so that we can visualize what's actually happening. So given that B is between A and C on a segment, so we have this long segment, and B is going to be between the points A and C, okay? And they also tell us that the segment AB is going to be 3x plus 1, and that BC is going to be equal to 2x minus 2. And they also told me that the full length of AC is 64 units. They didn't tell me centimeters or feet or whatever. But they want me to find the value of x, the length of AB, and the length of BC. So how are we going to set up an equation? So when you're given a geometrical picture or a situation and then you draw the picture, in order to solve for the things that we need to solve for, we have to get some sort of equation to start with, okay? So we know that this segment plus this segment is going to give me the full segment. That's my segment addition postulate that we just talked about. So that's how I'm going to set up my equation, okay? So I have 3x plus 1 plus 2x minus 2 is going to be equal to that 64 units. So now we just solve like normal. So combine like terms, that's 5x minus 1 is equal to 64. Add 1 to both sides, we get 5x is equal to 65, divide by 5, and we get x is equal to 13. But we're not done because they still want us to find AB and BC, which means we have to plug x back in. So that means that AB is going to be equal to 3 times 13 plus 1. Well, 3 times 13 is 39, so we're going to have 39 plus 1, which means that AB then is equal to 40 units. And then we have BC, which I'll do in green, is 2 times 13 minus 2. Well, we know that 2 times 13 is 26 minus 2. That means that 26 minus 2 is 24, so that is the length of BC. And we know, if we want to double check our mental math, AB plus BC should get us to 64. So 40 plus 24 is in fact 64. So that's example number 2 for you. And then here's the last slide for today, is other fundamental postulates in geometry. So remember, postulates are things that we don't have to prove. We'll talk about theorems in the future. I just wanted to explain in this video the difference between the two. Okay, so some more postulates that we can just take for granted and we don't have to prove. So number 5, through any two lines, there's exactly 1 point. Okay, we'll talk about this later in class 2. And then number 6, through any 3 points not on the same line, there's exactly 1 plane. So what we're saying is that if we have a line, there has to be a point on it. If we have a plane, there has to be at least 2 or 3 points on it, okay? And then a line that contains at least 2 points. And a plane contains at least 3 points that are not on the same line. So those are kind of all the same thing, 5 through 8. And then number 9, if 2 points lie on a plane, the entire line connecting those 2 points also has to lie in the plane. So if you're thinking about this visually, you guys, so we have a plane, right? We have 2 points with a line. So if those points exist on that line, they're also existing on that plane, okay? And then if 2 planes intersect, that intersection is known to be a line. So if we have that green plane and then we have this blue plane where they intersect is also a line. And we'll talk about that and we'll show you some visuals when you get back to class. But other than that, that's all I have for you guys. So make sure you get all this stuff written down in your foldable so that I can check your notes when we get back to class. And then I will see you soon. So thank you so much for taking good notes.